Okay, so I got bumped out again, so I'm not sure why it does that, but no matter. Hopefully the videos will, as they get recorded, they'll go to my email, hopefully, and then I'll just pick up and continue where we left off. So remember, we were on number 19. Sorry about that. We were on 19, and we were dividing by -21. And this can be reduced. This can be reduced by greatest common divisor of 7. So 7 goes into 7 one time. And -21 divided by 7 is a -3. Yeah, and sometimes people make the mistake and say the answer is just -3, but you don't want to make that mistake. It's -3 is not the same value as -3 is not the same value as a -1/3, and so you want to write that up correctly. Okay, and then I see in their solution set, I see that they're using a solution set. They have little curly braces, so they're just saying that people can also write up their answer like that. Okay, so x equals -1/3, and I see they have braces on that for that. Okay, so yeah, I always want it in lowest terms. Okay, then we're going to go to number 20. So 20, write the following inequality in interval notation and then graph it. So you have -1/2 is less than or equal to x. Okay, so this is saying that this x is representing all of our unknowns. Okay, and actually usually on the format, this is actually not a good format for an inequality. This is an inequality, not an equation, but an inequality. And usually on inequality you have usually the format is that you want to have your variable first, and then you have your and then you have your constant. That's really the correct, and then inequality and then constant. So yeah, so you see I just got kicked out again. So I think I'm going to change to my hotspot. Let me see if I can do that real quick. I don't know why it's doing that. Let me stop the share. Let me see. So sometimes if I go to my hotspot, that might work better. All right, so class, let's see if that works better. Let me see if my hotspot works better than the other internet that I was using. Okay, let's see. so we don't get kicked out again. All right, so I'm going to rewrite using the format. So I'm going to put my variable first, and then I'm going to put my constant on the other side. But then I'm also going to have to change this direction because I'm changing the format. And see how this is still pointing to -1/2, so we should still do that. Okay, so this is actually saying the same statement as this, okay? But the reason why we like this format is because when you have this format and the variable is in the front, this will help you tell you the direction that you're shading. So you see how the pointed side, see this pointed side? This is pointing towards the right. You're going to shade to the right. So this is saying that all our unknowns are greater than or equal to -1/2. So I have my number line. Here's 0. Here's, let's say here's -1/2. Here's -1. Make it a little bit longer. Even though we don't need a longer side, but just to give you a perspective, -1/2, -1, -1.5, -2, right? So here's -1/2. And this is saying all my unknowns are greater than or equal to -1/2. So I actually need the bracket on the -1/2 because this underscore, see this underscore? The underscore includes the endpoint. Okay, so that's why you don't want an open circle, which means you don't include it. You want to include it, so you do the bracket, and all my unknowns are going to be greater than or equal to -1/2. Okay. All right, and then you would look, if it's multiple choice, then you would look for your best match. And with mine, I'm looking on my computer first, but it looks like for me, it looks like it's going to be D. Looks like it's going to be the best choice. You can see my choices here, and then it's really light, but you can see it. This is here on -1/2, shading forever. Okay, so the graph for that, and then it wants, and of course it might be a different letter for yours. Everybody's got different numbers, and probably it may not be D for you. And so everybody's got different numbers generated. Okay, but this is the graph, and then it wants the interval notation. So the interval notation is a snapshot. It's a snapshot of the graph. It's a snapshot. It's like a picture, a mini picture, a snapshot of the graph. And we read graphs from left to right. We read graphs from left to right. And so when you read, and when you're reading the graphs, we're reading the shaded, we're reading like the shaded portions from, we're reading, where we read the shaded portions from the graph from left to right. So we're reading this from left to right. And this, when you shade it forever in the positive direction, that's called positive infinity, not negative infinity. Negative infinity is over here. So you start off at -1/2, and then you continue shading, 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 and you don't stop. Okay, so this is the snapshot. So you start here with the bracket at -1/2, and then you continue all the way to the infinity. And then by definition, because you have to have beginning and endings on your interval, this is an interval notation, and you need to have some kind of beginning and endings on your interval notation. So by definition, all infinities, whether they're positive or negative, They are associated with parentheses. Like the group with the grouping symbols, right? So parentheses. So that's how I know to put the parentheses on the infinity, because that's a definition. Because you can never like catch or identify an infinity, the last number on infinity, because someone can always take it out further. So you think, oh, I'm going to go up to 100. Someone can always take it out to 101, take it out further, 1,000, 1,001. So you can never capture an infinity. This is captured because it begins like it includes negative a half. That you can include, but you cannot put a bracket on infinity, because to put a bracket means you actually include that endpoint, and you don't have an endpoint on infinity because someone can always take it out further. So that's 20. So here's your graph, and there's your interval notation. Okay, then we're going to look at 21. Express a solution set of the inequality in interval notation and graph the interval. X is less than -7. Okay, so the format is good. The format, this is a good format. How do we know that? Because you already have the variable on this side, and then you have the inequality in the middle, and then you have the constant. So you don't have to rewrite it like that other problem we had to rewrite and fix the format. This is a good format. And this is saying that all our unknowns, or x's, all our unknowns are less than, not less than or equal to, there's no underscore. There's no underscore, just are less than the -7. So when you have your number line and here's 0 and -7 somewhere out here, all your unknowns have to be smaller, less than -7. So when we're shading this, we're shading, and remember I said that that's why teachers like to have the variable first, the format, because this pointed side, this tells you how it's shading. See, it's pointing to the left. See how this points to the left? And because this is the variable and this left, that means shade to the left. Shade to the left of that endpoint. Shade to the left. So you're going to shade to the left of that endpoint, which for us, that endpoint for us here is -7. And then you need the detail on the -7. So the detail on the endpoint -7 is parentheses, not a bracket. And why? How do you know that it's a parenthesis and not a bracket? I know it's not a bracket because there's no underscore. So if I had this, then I would have used a bracket. But since I don't have this underscore, I just have that, it's a parenthesis, okay? And I know in high school they use open circle and closed circle, but in the colleges we don't use the open circle and closed circle because we also do interval notation. And the interval notation, it's not helpful to use open circle and closed circle because that doesn't help you with the interval notation. But the brackets and the parentheses do. We can use brackets and parentheses in the interval notation. So that's the next thing. I think they're also asking for the interval notation. And remember how we read graphs. Remember we read the shaded part of graphs, remember left to right, to help you with the interval notation. So you see this is negative infinity. So you start with negative infinity. And remember by definition, All infinities are associated with parentheses. That's by definition. So that's why I start from negative infinity all the way, and I stop at -7. And then I need to describe this ending part, which is parentheses. Okay, not a bracket, no underscore. Okay, so that's the interval notation for 21. Okay, then we look at 22. And I see they want you to graph this inequality. This is what my computer program gave me when I printed my computer printouts. And this is called a compound inequality. And slang we call it a sandwich inequality. So our unknowns are trapped. Our unknowns, our x's, our unknowns are trapped between two real numbers. So they're trapped between 0 and 8. And they include 0, but they don't include 8. So you see the underscore? They include 0, but see this? They exclude 8. So include 0 because of the underscore, exclude 8, no underscore. So here's 0, and let's say 8's over here. And so I want to shade everything in between 0 and 8. And then I include 0, so I need a bracket, but I want to exclude 8, so do a parenthesis. So there's your graph. And then remember that your interval notation, you're reading your graph, you read, the shaded graph, again, from the left to the right. And so you begin here with this bracket on 0, comma, and then you go all the way out to the 8, and then parentheses on the 8. So that's your interval notation. It's a snapshot. It's a snapshot of your graph. Okay? Okay, now we go to 23. -9x is greater than -27. Okay, so here you're going to have to do a little bit of solving. You're going to do a little bit of solving. And again, they say use the multiplication property of the inequalities. Really, it's division. In math, we undo multiplication by division. So really here, to solve this, here I want to divide by the coefficient, which is the -9. The number in front, the coefficient is the coefficient number in front of that variable there. Yeah, and there is no need to use the addition property of equality. Like there's no need to like move a term, a constant over, add the opposite or subtract the opposite. That there was no term here. This is just -9x. It didn't have like -9x plus 10 or negative 9x take away 10. Didn't have that where I had to move that 10 over by using opposites, so I got to skip that. But I do have to divide both sides by negative 9. And a negative divided by negative is a positive. So negative 27 divided by negative 9 is 3. Okay, but then something really important happens here. Okay, and there's a rule when you're solving inequalities that say that whenever you divide by a negative number or whenever you multiply by a negative number, you're required to change the direction of the inequality. Okay, so that's why this direction will change this way. Okay, and so that's a rule that whenever we divide by a negative number, whenever we divide, let me say divide an inequality. Yeah, because that doesn't happen when you have an equal statement. That only happens because an equal statement is still equal. That doesn't happen when you have an equal statement. It happens when you have an inequality. So whenever you divide an inequality by a negative number, or whenever we have to multiply an inequality by a negative number, then we must change the direction of the inequality. Okay, so that's super important there. Okay, that's super important. Okay, that's why I didn't do it on any of the other problems earlier today, because we didn't actually have to divide. Like when I did this one, like it was already set up. I didn't have to solve for it, and I didn't have to divide any of those. But this one I'm having to solve a little bit, solve that, divide by negative 9. So it only happened because I divided by negative 9. If I had, like, just making this up, 3x is greater than 81, and then I divide, oops, let me do this, 3x is greater than 81, and then I divide both sides by 3, and then I use my calculator, 81 divided by 3 is 27. This is x is greater than 27. So here the direction doesn't change. Here, the direction of the inequality doesn't change. And why? Because we didn't divide by a negative coefficient. I just divided by 3. Just divided by 3, not by a negative 3. So here I didn't have to change the direction of inequality. But over here I divided by negative 9, so I had to change the direction. Okay, so this is what we get when we solve it on 23. And then let's see, I think they want you to graph it, and I think they want you to make a interval notation. Yep. Okay, so when I graph that, so here's 0 and here's 3, and this is saying that all our unknowns are less than 3. Not less than or equal to, just less than 3. So when I shade, and see how this is pointing to the left? Again, you want your variable on this side on the left, inequality constant. So see how this is pointing to the left? So you want to shade to the left of 3. And then the detail on 3 is you want to use parentheses. Okay. All right. That's the graph. Okay, and then the interval notation. Okay, so we read it from left to right. So this is negative infinity. Okay, so parenthesis, negative infinity. You need detail on the infinity. All infinities are associated with parentheses. It's by definition. And then you have this 3 here, and then you need, see, parentheses. No bracket because no underscore. Okay, so that's your interval. That's 23. Okay, then 24. X is greater than or equal to 3, or X is less than -1. Okay, so it says solve the compound inequality. Use the graphs to show the solution set to each of the 2 given inequalities, as well as a third graph that shows the solution set of the compound inequality. Okay, so it looks like they're trying to help you by giving you parts. So like they want you to first work with this, that X is greater than or equal to 3. See how this is pointing to the right of 3? So they want you to find the graph for that. So here's 0 and here's 3. So X is greater than 3. And see the underscore? So the underscore means that you want to use a bracket on that endpoint 3, and you want to shade it to the right of that. Okay, so that would be, you would look on, everybody's got different examples, but that's kind of the idea you would do, is you would look at your graphs and look for that. And then you want the graph for this, X is less than -1. This one was X is greater than or equal to 3. This is X is less than -1. So you're shading to the left of negative, all I know are less than -1, and it doesn't have a bracket, so you're going to use parentheses, and you want to shade in that direction. So you see also how your parentheses is shaped? See how this is shaped in the direction that you're shading? Okay. So then you look for the graph that matches that. And then now you want to look for the combined graph for this. X is greater than or equal to 3, or X is less than -1. So then you want this combined graph. Okay. Yeah. So then we've got this idea. Let's see. So you want to look for that answer choice that reflects that. Oh, and then they also want, they do want an interval notation. Okay. Now, since this is a compound, this is a compound inequality, which is means like it's, you know, made up of at least two two inequalities, and these are going in opposite directions. So when you make your interval notation, because you have this leap in the middle here, you are going to have to make use of a union, which is a U, to join them. So we do read graphs. We do read graphs from left to right, and we do, keep track of the shading. So when we do that, we read from left to right, and you keep track of the shading. So this reflects negative infinity. So you have parentheses, negative infinity, all the way to this -1 and parentheses. But then you have this jump, this you need this disconnection, right? So that's where we use the union to reflect this gap. And then you pick up 3 to see, this is infinity, shaded forever in the positive direction. And remember, all infinities are associated with parentheses. And that's by definition, and also by L'Hopital, the mathematician. L'Hopital's work with limits. Okay, then we're going to look at problem 25. And we're solving 6/7 x equals 20. Okay. Okay. So this I always teach my students that, when we're solving for x, you want to isolate your variable. And I always teach them here that in this case, when we have fractional coefficients, this is what I teach, is that when we have fractional coefficients, and that's numbers, coefficients are numbers in front of the variables, and we're talking about fractional coefficients. So numbers in front of the variable, that are fractions. What we do when we have these, we train to multiply both sides of the equation, what you do one side to the other side, by its reciprocal. And the reciprocal of a 6/7 is a 7/6. Okay, so I have here 6/7 equals 20. I'm going to put 20/1, and I'm going to change my ink and put a times on both sides, and I'm going to show multiply by 7/6. Okay, and then I'm going to show how these divide out. 6 goes into 6 one time, these divide out. And I'm also going to show that these divide out. 7 goes into 7 one time. So all we're left with is just x. And then on this side here, again, how do we multiply fractions? I'm going to just multiply straight across and then reduce. So 20 times 7, 0 times 7 is 0, 2 times 7 is 20 times 7 is 140, 6 times 1 is 6. And I'm going to just reduce by 2. 140 is 70, and I can show that here. 140 divided by 2 is 70, and half of 6 is 3. 6 divided by 2 is 3. And I don't think that can be reduced anymore. If you think that that can be reduced by 3, we can check. 70 divided by 3. Yeah, see how you get a decimal? Yeah, so then yeah, you cannot reduce that. So that's an improper fraction. And let me just check that. Let's see. Okay, and I see that they didn't actually solve it. They just wanted, they're asking how can it be solved? So it can be solved by multiplying both sides by 7/6. And yeah, and you want to know how to solve that. So on a test, you would also want to know how to solve that. And so you multiply both sides by the reciprocal, and that would give you 70/3. And if you want to make it into a mixed number, the mixed numbers look like this. Then you do long division. To make 70/3 into a mixed number, you do long division. So 3 goes into 7 about twice, that's 6 times. 7 minus 6 is 1. Bring down the 0. And then 3 goes into 10 about 3 times. 3 times 3 is 9. 10 minus 9 is 1. And then that's the remainder. And then you record it like this, clockwise, record clockwise, the movement of the clock. So this 23 becomes your quotient, or your quotient becomes your whole number. The r, the remainder, becomes your new numerator. And then the denominator usually stays the same. See, denominator is your divisor. Yeah. And if you do a check, 23 times 3 plus 1, so you get back to 70. Yeah, 70/3. So 23 times 3 plus 1 gives you back to 70. Could you do a check? Yeah, and speaking of check, there was one problem, right, that they wanted us to do a check. I don't remember which one that was. I think I forgot to do the check on that one. Let me go back. I think it was number 18. I think 18 said solve the equation and then check the proposed solution. I didn't go, let me go back to 18 because I don't think I didn't check that, and I just remembered that because of this one. I was just doing that little check just for that. Let me go back to 18. And when I'm done with all these, I'm probably gonna have quite a few recordings to put up, but when I'm done, I will make a PDF of all these and put them up as well. But on 18, wanted to also to check. So what you would do with a check is you would basically substitute your answer. So our answer is -2. So you would sub -2 for your letter, your variable y. So here I have -3 times -2 minus 12, and I'm going to put a question mark. Does that equal -6? So -6 minus 12, That's 6 plus negative 12. Yeah, which is a negative 6. Yeah, so negative 6 does equal negative 6, so that's true. So if it's true, that means it's a solution. If it's false, that means it's not a solution. So that means we did this right. We were trying to solve this, and if this is the right answer, when you go back, plug and chug, when you go back, that commercial, plug it in, plug it in. Yeah, so when you go back to that commercial, that's a math teacher's favorite commercial. Plug it in, plug it in. You go back and plug that in, you should get a true solution, a true answer. And we did. Left side equals right side. Negative 6 equals negative 6. All right. Okay, so that was 25. Okay, let's see. Okay, then I'm looking at negative 26, and it says fill in the blank so that the resulting statement is true. So it says that let me see, mine says that the equation 3x plus 8 equals 18 can be solved by first, and it has a blank, doing something to both sides, and then it has another blank, doing something both sides by blank. And then you have some choices. So let's see. So if I think about this, 3x plus 18 equals 18, well, I would think, how would I solve this? So first, to solve this, I would think about moving this 8 over here, this constant over here. So I would use opposites. Opposite of plus 8 is a minus 8, so that this will fall out. So then you have 3x equals. So I would look, the equation 3x plus 18, 3x plus 8 equals 18 can be solved by first, and I look at my choices, I would say subtracting, I did subtracting 8 by first, subtracting 8 from both sides of the equation, okay? And 18 minus 8, that's just 10. And then what would I do to both sides? Then I would divide both sides by 3, my coefficient. So I look at my choices. So I see subtracting 8 from both sides, and then I want to dividing both sides. And you're dividing by a 3, not by a 10. You don't divide by the 10. 10 is called the constant. 3 is called the coefficient. So you wanna divide by the coefficient, the number that's in front of the letter. Okay, and then if you can reduce that, you would reduce that, but 10 over 3 cannot be reduced. Now if you want to make it a mixed number, you do long division. The numerator goes inside the house, and 3 goes into 10 3 times. 3 times 3 is 9. And you subtract 10 minus 9 is 1. That's your R, your remainder. And then it goes clockwise. So that's 3 1/3. Okay, then if I look at 27, solve the following equation, 6m equals 0. Okay, so again, do you want to isolate the variable? So you should show on your paper, dividing both sides by 6. These, and then m equals 0 over 6. And remember, this spells on, remember, 6 is 0. So m equals 0. And again, I see how they also have these little curly braces. Sometimes you can put your answer in a solution set. That's how I see that there too. That's also true. Okay. 28. Solve the equation. 3x plus 3 minus 6x equals 6 minus parenthesis 3x plus 3. All right. So again, we're trying to solve for x. So here I see something different we haven't seen before. I see the need to combine like terms on the left side of the equation, which is important. And then also I see something else important on the right side. I also see the need to do distributive property on the right side. Very important. Yeah, we haven't seen that before. Very important. Okay, so on the left side, when you're combining like terms, you know, we're working with, if I stack them, I'm working with this 3x and with this negative 6x. See this 3x and that negative 6x, 3x plus a negative 6x, and you're adding two numbers with different signs. So you got to ID your sign and then subtract. So it's going to be a negative, and when you subtract 6x minus 3x is 3x. That's a negative 3x. So now I have a negative 3x and then that plus 3 equals, and then on this side, here's my distributive property, and there's like an imaginary negative 1 here, and we distribute that. So this side I have this 6 and I have this negative 3x. Negative 1 times 3x is negative 3x. Negative 1 times 3 is a negative 3. Different signs produce negative results. Different signs produce negative results. Okay? Okay, and then when I try to combine like terms on this side, I see how I can combine the 6 and that minus 3. See, 6 and that minus 3. So 6 minus 3 is just 3. So on this side, I have this negative 3x and then that positive 3. And look how that's identical. See how you have, this is called an identity. This is an identity. This is an identity. See how the left side equals the right side? That's an identity. That means that we should have, I see the choices there. That means we have like an infinite. I've learned it first in school that we have an infinite amount of solutions. And I'm looking at your choices here, and that means that we have all real numbers are solutions. And that means that to solve this equation, it's all the real numbers in the world that, you know, if you let x be 0 and you plug it in here and you plug it in here, you'll get a true statement. The right side will equal the left side because these are already identical. These are ID, like ID, you see yourself back in the mirror, identification, these are equal, identity. So whatever you plug in here and you get a value and compute, it's going to be the same over here. So it's going to be true statements. So all real numbers are going to be solutions and make true statements. Okay. And see that here, you know, you see that this is an identity. The left side equals the right side. You can stop right there and you see that. You just make a statement make your conclusion. If you want to keep going, you can keep going, and if you keep going, then you would like, let me show you boxes. If you were to keep going, like you would move these x's over, so you would like add 3x here, add 3x here, and then these zero out, those zero out, so then you have 3 equals 3. See how it's still an identity, still identical? Left side equals right side. If you want to continue with that, you could subtract 3, 0 equals 0. See that? Still left side equals right side, still an identity. Yeah, so that this is a special case. Yeah. So when you're solving an equation, three things can happen. Either you get when solving an equation, there are three things that can happen. There are three cases. So either you have one solution, like a while ago when we did 26. A while ago we did 26. We solved this one. We got one solution. And that's called a conditional equation. Okay. Or you can get infinite solutions, which is this, all real numbers, many solutions. Or the other thing that's going to happen is you can get no solutions. And I think that's what's happening on 29. I think I'm going to show you that later on tonight. I'm going to take a little break, but I think that's what's happening on 29. And so when we continue, I'm going to take a break now, and when I come back and continue the video recording, we'll show you the no solution on number 29, I believe. So but those are the three things that can happen. You either get one solution, or you get infinite solutions, which means all real numbers are solutions, or you get no solutions. Yeah, and on the tests, it would be important for me to test you on all three of those to show that you can demonstrate that happening on that. Okay. All right. Okay. So let me just look at this. So where we stopped, this is where I'm going to take a pause. Okie doke, great. All right. Okay. So we'll stop here, and then I'll pick back up, so in the recordings. All right. Okay. All right. Bye-bye.